All of the GS4 drives from Automation Direct have 3 analog inputs. Analog inputs 1 and 2 have switches on a terminal board so you can switch them between current and voltage modes. Analog input 3 is a dedicated 10-volt input. When analog inputs 1 or 2 are switched to current mode, these parameters allow you to switch between 0 to 20 milliamps and 4 to 20 milliamps. The cool thing about these analog inputs is any of them can be used for any of these functions. You can use them to control the frequency of the drive, as a PID set point, feedback, or offset, or even use them to monitor the temperature of the drive and automatically generate warnings or faults. So all of that means you can use the default mode, where the analog input controls the drive frequency linearly from 0 to 60 Hz from any of these analog input types. You can increase the gain to increase the maximum output frequency. You can add in an offset so the motor has a minimum non-zero speed. You can split the range so half of it drives the motor in a forward direction and half drives it in reverse. You can have most of the analog input range drive the motor in a forward direction, but use the rest of the range to jog the motor in reverse. You can reduce the gain to reduce the maximum output frequency. You can completely change the slope of the curve by adjusting the offset and the gain. You can trim the response using a fixed value or even another analog input to make the trim variable, and you can even create a custom volts-hertz curve. The flexibility of the GS4 drive analog inputs is awesome, and the best part is there is examples in the user manual at the end of Chapter 4 that show you step by step exactly how to do each of those typical frequency control setups. Let's do the first example using analog input 1 to control the full frequency range of the drive with a local potentiometer so we can manually control the drive if we want to. Since the potentiometer is applying a voltage, we need to make sure the switch for the analog input 1 is set to voltage. Now we need to tell the drive what we're doing. We'll use parameter 401 to set the local frequency source to use the analog input as its reference. That'll leave the remote frequency source available for something like a PLC to control the drive. For the rest of this, let's use that handy analog input reference chart in Appendix C as a checklist to make sure we don't miss anything. First, we tell analog input 1 that he is the local frequency source. Analog input 1 defaults to 0 to 10 volts, which is what we want, and we don't want to change the curve with additional bias or gain, so we'll leave those at their default values. We're using a potentiometer, so we really don't need any additional filtering, and you only use this stuff if you want to modify the curve. Well, that's it. If I tell the drive I want to use the local controls and enable it, sure enough, now I can control the motor speed from the potentiometer. And if I dial in 0 volts, the stop LED blinks telling me the motor's enabled, but at a 0 speed. Perfect. What if we wanted to control both forward and reverse, which is plus 60 Hz to minus 60 Hz, from the 0 to 10 volt potentiometer? Example number 4 in the user manual shows us that all we need to do is dial in an offset. We want to shift the curve down 60 Hz, or 100% of the max frequency, so I'll enter a minus 100 in the analog input 1 offset parameter. And since we did that, we need to double the gain to get the full range back, which is parameter 412. We need to enable the offset in parameter 411 for analog input 1. We used a negative number for the offset value, so we'll use this positive enable. We could also have used a positive offset and then told it to invert it here by using a negative enable. That's so if you have a PLC that can only write positive values, you can invert them here. Finally, in parameter 409, we tell the drive to use the analog input for forward and reverse instead of the keypad or external terminal. Now if we enable the drive, sure enough, full left on the potentiometer is full reverse, the midpoint is 0 speed, and full right is full forward. Perfect. Well, that should be enough to get you started. In part 2, we'll use an analog input for temperature control. That's where the drive can use an analog input to monitor the temperature of the motor and shut itself down if the motor gets too hot. In part 3, we'll go over some loose ends that will help you get the most out of using analog inputs on your GS4 drive. Click here to learn more about GS4 drives. Click here to learn about Automation Direct's free support options, and click here to subscribe to Automation Direct's YouTube channel so you get notified when we post new videos.